All right, guys, this will be the last video for today. We just have two problems to do. Okay, still working with inverses. Okay, so we'll see what happens here. Okay, I want to take a look at this guy. Okay, what's that look like? Okay, well, I know if I just had the square root of x, if I just had this, y equals the square root of x, that would go from the origin, and it would sort of be like the top half of a parabola that opens to the right. So it's going to look like that. So since the plus 9 is underneath, it moves it 9 to the left. So that'll bring me over to negative 9 right here, and that guy will do this, okay? Look like this, okay? All right, so that is, okay, the original function in this problem. Okay, that's my f of x. So it certainly looks like if we apply the horizontal line test, it's definitely gonna pass the horizontal line test. So we should have some good stuff going on, okay, with finding the inverse. Okay, so let's see. So again, I'm just gonna continue to refer back to this guy, okay? So it looks like it's going to pass the horizontal line test. Okay, so I get it out of function notation, and I write it as y equals the square root of x plus 9. Okay, and then I switch the x's and y's, so I'm going to get x equals the square root of y plus 9, like that. Okay, so I've got to isolate y. Okay, so to do that, okay, I need to square both sides to first get rid of the square root. So I'd get x squared equals y plus 9, and then subtract 9 from both sides. So I get x squared minus 9 equals y. Okay, so I go back to my function notation, and obviously this is an inverse, so it go back to f inverse of x equals x squared minus 9. Okay, all right, so, you know, will this function as an inverse everywhere here? Okay, we don't know yet. Okay, got to take a look at what's going on. So what's this guy look like here? Okay, well, we know that's just a parabola, okay, that opens up, okay, and it goes through 0, negative 9, like this. Okay, so I'm just going to have a parabola that opens up. Oh, that's a bad looking parabola. Okay, right here, not a good looking parabola at all. Okay, so let's take a look at our domains and ranges and see what's going on here. This is my f inverse of x, and let's see if things work out here. Okay, so I look at f of x, and I look at my domain and my range, okay, and then I'll do the same thing with f inverse of x, look at my domain and my range. Okay, so over here, we take a look at, you know, for the domain, what values along the x-axis, okay, will be included. So notice it starts at negative 9, and it includes negative 9, and it goes forever to infinity on the x-axis. So I would have negative 9 to infinity here. Okay, and then the range, well, it's going to start at 0 on the y-axis and go up forever. Okay, so I'd have 0 to positive infinity on the y-axis. All right, now over here, okay, it looks like, well, my domain here, it looks like I can go anywhere on the x-axis at all, okay, and it'll work out. So that would be from negative infinity to positive infinity, or just a set of all reals, okay, like that. Okay, so my range on the y-axis, it looks like it starts at negative 9 and goes to positive infinity. Okay, and we see, you know, do things match up here? Okay, so if you look at the domain here, okay, and that takes us down to the range here, so that works okay, so that's good. But then if you look at the range here, okay, look where it takes you down to the domain here, things don't work out. Okay, so it looks like right here, okay, and here, okay, we've got an issue. And it's the first time an issue has shown up, and that's what happens a lot on these problems, okay? You've got some issues there when you start at the very end, start comparing domains and ranges to ranges and domains, okay? So the important thing is that we can come up with this function, okay, that acts as an inverse. It just might not always be an inverse everywhere, okay? So, but the important thing is we can come up with that function, okay? And we're gonna encounter these kind of issues, and it's okay. It's good to talk about them. You know, why is there an issue? And, you know, at some point we'll talk about how do you deal with that issue, but right now it's probably not the right time. Okay, so one more problem. Okay. All right, so let's see. All right, this guy right here, we take a look at what it looks like here. Okay, so notice the parent function of this guy would be y equals x cubed, okay, which looks like this right here, okay? And you learned that in Algebra 2. Okay, so if I have x cubed and I subtract 20 or add negative 20, all it does is take this and bump it down, okay, 20 units, okay? So this guy will, rather than going through the origin, okay, it's gonna go through negative 20 on the y-axis. So this guy's gonna do this, okay, and look like that, okay? And so that's my g of x. Okay, all right, so again, okay, notice it looks like it passes the horizontal line test, so we should be able to find, okay, an inverse. Just are we gonna have some problems at the end like the last problem where you're dealing with some issues with the domains and ranges of the original function compared to the domains and ranges of the inverse. Okay, so let's see. All right, so we get it out of function notation, so we write it as y equals negative 20 plus x cubed. Okay, then we switch the x's and y's, so the y becomes an x and the x becomes a y. Okay, and so now I have to solve, okay, for y. So if I'm going to solve for y, I got to get the y by itself. So let's bring this negative 20, move it over and change it to positive. So I get x plus 20 equals y cubed. Okay, and then to be able to get y by itself, I've got to get rid of this cube. So that means I got to take the cubed root of both sides. Okay, cubed root of both sides. Okay, so I end up with, okay, y equals the cubed root of x plus 20. Okay. All right, so let's see. So I go back to function notation, and obviously it's going to be an inverse. Okay, so g inverse of x is the cubed root of x plus 20. Okay. All right, so we want to take a look and see what that looks like, okay, on a graph. Okay, so if I was just doing y equals the cubed root of x, okay, well, a root we know is going to look something like this, okay, but notice we can take an odd root of a negative number, okay, so that means I can keep finding these guys over here. So this guy would look like this, okay, if it was just y equals the cubed root of x. Okay, now, since I have this plus 20 underneath, what it's going to do is take that guy and move it 20 units to the left. Okay, so over at negative 20, okay, it'll do this. Okay, it'll go like this, okay, and then it'll keep coming underneath like that. Okay, so this is the guy we're looking at right here. Okay, pi equals the cubed root of x plus 20, like that. Okay. All right, so last thing, we take a look, and obviously this is the important thing. We can come up with this function. That's the most important thing. Okay, and then if we take a look at, well, what's going on with our domains and ranges here, see if things work out. Okay, so I go to g of x and look at our domain and our range. Well, here, notice that no matter where I go on the x-axis, okay, those values are included because I can put any number at all, okay, in the original function. Okay, so that's the set of all reals, which again, okay, you could write as negative infinity to positive infinity if you wanted to. Okay, and then if we look at the range, notice everything on the y-axis is included as well. Okay, so that guy's in good shape. Once again, if you want to go negative infinity to positive infinity, you can. Okay, now if I go over here to my G inverse, okay, so my G inverse of x, okay, and I look at my domain and my range like this. Now remember, we're working with this guy right here, okay, right there. And so if I go along the x-axis, notice that every value on the x-axis, okay, is included because I can put anything in here because I can take the odd root of a negative number, okay? So notice it goes the set of all reals. And then if we look along our y-axis, well, this guy keeps going, so he's going to keep increasing, so it's going to keep going up towards positive infinity, and this guy will keep going and keep decreasing, so it goes down to negative infinity. So again, it's a set of all reals. Okay, so we look here, is the domain of the original function the same as the range, okay, of its inverse? Yes. And is the range of the original function the same as the domain of its inverse? And that would be yes. So notice on this one, we didn't run into any issues at the end like we did in the last problem, okay? And every problem is different, so sometimes there's going to be some issues, okay? You know, like we had on this guy, there's going to be some issues at the end, and sometimes there's not. The most important thing is that we can come up with the function, okay, like here and here. And that'll wrap it up for videos today.